Alright, so this is our problem. We have the integral from pi to infinity of e to the negative x sine x. Why you would ever need to know this for any practical purpose, ask Miss Stanley and I'm sure she'll give you some crazy answer that won't make any real sense. But this is our problem. So the first thing we of course have to do is replace the infinity with the limit as b approaches infinity, or use whatever letter in this language or other language that your heart desires. So we do that, and now we realize that we have to do integration by parts because we have a product here. So the best way to do integration by parts is we realize that both of these are just going to take us in a loop back and forth. There's the sine cosine loop of derivatives, and e to negative x is obviously just going to keep going negative, positive, negative, positive. So what we need to do is we need to pause for a second and think. The way I take these derivatives and the way I sign u and dv needs to be in such a way that after I do it twice, I end up with minus this integral. So I can add it back over to this side of the equation and then divide what I have left by 2. So basically the way you do this is you just have to keep it consistent as to which variables you have with each part of the equation. So essentially u is e to the negative x. Next time you're going to want u to be e to the negative x. And dv is sine. Well, so we know that we want the sines and cosines to be the v's, and we want the e's to be the u's, is essentially what I'm getting at. So we do this, and our product rule works out so that we get negative e to the cosine x, which, you can see. You gotta have the u and the negative cosine x, so negative e to the x cosine x minus the integral of e to the negative x cosine x, which again, that's just v and du down here multiplied. The two negative signs cancel out, but you still are supposed to have a negative. So we need to do this one more time. And again, we're just going to keep the e's in the same place with the u's, e's and u's, and the cosine and the sine with the v's. So we just do this, and it'll work out that if you see it, we're going to have, well, you'll see it over here. We have negative, or minus e to the negative sine x, to negative e, I'm sorry, a lot of negatives and x's. Minus e to the negative x sine x. And if we look down here, we would have sine x times minus e to the x. And since we have this minus sign up here, since we have this minus sign up here, and we'd have a second one of these within this integral, the minuses cancel out perfectly and everything works out. So we just have the limit as b approaches infinity of, well, this. And you just solve it out. And I'll just, 1 second, gotta get my chalk. I told myself I'd leave solving it for the end. So we're going to have, alright, so at pi, sine of x is just 0. So we're going to get minus negative e to the negative x, well, not to the negative x, to the negative pi, my bad, times cosine of pi, which is just 1, over 2. So we have this so far. And then for the part with b approaches infinity, well, as b approaches infinity, e to the negative x will become e to the negative infinity, and that's just 0. So this whole thing in front is 0. So this is our answer, and we just cancel out the two negatives, and we're going to get e to the negative pi over 2, which is again a really weird and silly answer, but it's the answer. I don't know why you ever need to know this. Take it up with Miss Donnelly.